In this video, we will learn about structure as a parameter. If you are sending a structure as a parameter to some function, it may be called by value or called by address, right? Call by reference is there in C++, so I will show you call by reference also. So first let us look at call by value method. See, for that already I have an example. This is a structure rectangle having length and breadth as the members. Then I have a main function having a variable of type rectangle and it is initialized with 10 and 5, so a variable is created with values 10 and 5. Now I want a function to calculate the area of a rectangle by multiplying length and breadth. So I want to write a function called area. So this function, the skeleton is already here. Now what I should pass from here? Shall I pass length separate, breadth separate? No need. You can send the structure itself. Yes, that is the benefit of structure. You can send the structure itself and the structure is carrying length and breadth. So both will be passed as parameter. So it will be passed as a single variable, single data member. So write R here. So structure is passed as parameter. Now what should be the parameter type of this one? So the argument type should be struct rectangle R. So it's rectangle R. This is called by value. So instead of R, I will say R1. Just a change of names. You should not feel that they are same. This variable is different, that variable is different. So I have taken parameter as R1. Now that is called by value because here I did not write any asterisk or I did not write ampersand. This is called by value. So in call by value, what happens? This object or this variable is passed by value. So a new variable will be created here, a new variable R1, and it will have its own member, that is length and breadth, right? So the values will be copied here. So it means separate object will be created. Yes, separate object will be created in call by value and everything will be copied in the corresponding members. This is the benefit of structure. This is one more thing, one more useful feature. Now here what I want to do, just calculate area. So I have to multiply length and breadth. So directly I will write down return. I will directly write in the return statement R1 dot length. So R1's length, right, into R1's breadth, R1's breadth. That's all. It will return the result and this printf will print it. This is call by value. Now one thing, inside this one, if I make any changes, if I say R1 dot length plus, if I modify length before returning, so this becomes 11. So will it change this one? No, it will not change that one. It is called by value. So the actual parameter will not modify. This is actual parameter and this is formal parameter. If you're making changes to formal, it will not affect actual, right? This is one thing. Now next I will show you call by reference. Call by reference. So for call by reference, I don't have to do anything much. It will be same thing only, and only the thing I have to do here is I should write ampersand R1. Now this is a reference. So a new object will not be created, but the same thing is called as R1 also. Yes, we have already learned about the references. So the same thing is called as R1, and you know very well that this will not be a separate block of machine code. It will be pasted at the place of function call. We have already learned about this. Only there I have to write ampersand and rest of the things remain same only. Then if I say R1 dot length plus, yes, this will modify. This will become 11. That same thing gets modified, right? So though for calculating area, I don't need call by reference. For calculating area, I need call by value because it is just supposed to read the values. So you should know very well that which function should use which method for parameter passing, right? So this needs call by value, but also I have explained you about call by reference, how to do that. Now in that reference, I can use dot operator. Yes, dot operator, simple as a normal object or normal variable. Now next I will show you call by address. So for that, I will change the function, right? I will write down another function for call by address. Now for call by address, I have changed an example. I am calling a function name as change length. Suppose I want to change this length, right? I want to make it 15. So I can make changes here also. I can make changes here also. No, I want it to be done by a function. I don't want to do anything inside main function. Like main function, we should imagine it like a manager, and he's having all his assistants, and he don't want to do anything by himself. He just want to assign the job to all his assistant. He knows how to do the work, what the work should be done. So every work he will assign to assistant. So we should imagine like this. So main function can change, but main function is not doing it. Assistant will do it. So that is change length function. So this, we want this function to change this length. So when you want some function to modify actual parameter, then it must be call by address or call by reference. So we are learning call by address. Let us write call by address. First of all, from here I should call that function. So yes, I should call that function change length, right? Then what is the parameter I should pass? Rectangle. By address, so I should pass ampersand address. So here what it should take? It should take it as a pointer. So struct rectangle pointer, right? Star P. Then along with this also I should pass the new length. So let us say I want to make the length as 20 instead of 15, let us say 20. Then it should also take new length, so it is integer L. So it is taking by pointer. So when you call this function, how it looks like? This P is a pointer that belongs to this function and is pointing on this one. Now we have already learned pointer to a structure. So now you can see that pointer to a structure is useful in parameter passing also. I want to modify that length. So say P arrow, because for accessing this member indirectly using pointer, we have to use arrow. P arrow length assign L. So this length will be modified to 20. That's it. So this is how we can use call by address for the structure. So this type of thing I have used in my course. So whenever I am writing structure and function, so wherever I have to make changes in a structure, I am using call by address because I am writing C language code, right? So basic code I am writing in C language only. So I have used call by address. So from here I am setting an address, and there I am using a pointer, and by using arrow I am accessing the members. So you should be familiar with this code, and if you are comfortable with this one, then you can smoothly follow the rest of the topics, right? So this is the method for call by address. Now one more thing I have to show you. I'll remove this and I'll explain you. Yeah, one more thing that I have to show you. I have written a structure here having a array as a data member and one more integer data member. Two data members I have taken. Mainly array is important there. So we focus on array. Then here inside the main function I have created a variable of that type structure test, and the name is T, and I have also initialized it. So it will have two members, array and n. So array, the size of an array is 5 and one more integer variable is there. So all are initialized. Now, can we send a structure as a parameter in call by value? Yes, call by value can send. But can you send an array as call by value? No. Array can be sent only by call by address. Already we have discussed this in previous videos. Then, but this structure is having an array. Can you pass this by value? Yes, structure you can pass by value even if it is having a array inside. So that's it, the important thing we are learning now. So here I have a function called fun, and I am taking it as call by value. So from here I am passing T. So whether it works? Yes, it works. So what happens when this T is passed? So again a new T1 is created with an array, right? And also n, and everything from here will be copied here. 2, 4, 6, 8, 10, and also value 5. Everything will be copied. So when a structure is passed by value, even if it is having an array will be created separately in the member and it will be filled. So imagine all these values has to be copied. Automatically it is done by the compiler. So this is time consuming. That is the reason compiler doesn't support arrays by value. They allow only call by reference. But if it is inside the structure, they support it. They have to do it. So this will be copied. Right? We are not copying it. Internally it's happening, means compiler will do this one. So yes. Now if I make any changes, how I can access this one? I can say t.a because it's own member, right? It's called by value. And I can say t.a of 0 assign 10. So this will become 10. right? So I can change the value. T1 of 1 assign 9. So this will become 9. This value becomes 9. But this will not change because this is call by value. So I can use dot operator and access the members. So that's all. We have seen how we can pass structure as parameter. We have seen call by value, we have seen call by reference, we have seen call by address. Then also we have seen that even an array is there inside a structure, it can be passed by value. Structure can be passed by value. That's all in this video.